Hi everyone, how are you doing? Thanks. I'm so excited to be here right now and finally be able to look at you from this stage, from this view. And I should say that you look incredible. And today I would like to share with you a story about how we do platform engineering in Electrolux and how it specifically streamlines our API development. But what is Electrolux? Electrolux is a global leader in home and connected appliances originated from Sweden. We have more than 20 sub-brands, but we're most known for AEG, Electrolux, and Frigidaire. And Electrolux has a very long history. It's more than 100 years old. And sorry. Thanks. Yes. So here you can see a vacuum cleaner from 1960s. Looks very retro. I would love to buy one. And in Sweden, people are really passionate about appliances. And I will show you why. So this cake is a very popular one. You can buy it anywhere, like basically in every bakery or grocery store, which is called dammsugare, which we can translate as vacuum cleaner. So I hope that you can see some pattern here, right? So in Sweden, Electrolux and home appliances is not just another company on the market. It's a whole culture layer. But who am I to talk about it? My name is Alina Astapovich. I'm site reliability engineer in Electrolux. And 3 things that you might be interested to know about me. First of all, I moved to SRE team from being a Java backend developer. I'm certified AWS solution architect, and I have a master's in neurotechnologies and software engineering. And today, I have a small celebration that I want to share with you. It's exactly 4 years since I started to work at Electrolux. And I hope, thank you. And I hope that from this session, you would understand what is keeping me so long in this company and why I'm not moving back from Sweden. It's fucking cold there. So in Electrolux, we are splitting all appliances into 3 main domains: care, taste, and well-being. So taste appliances is basically anything that you can find in your kitchen: fridges, hobs, ovens, toasters. Care appliances will take care about your clothes: washing dryers, washing machines, tumble dryers, steamers. And well-being appliances will make sure that your environment is being well, like air purifiers and humidifiers, vacuum cleaners, but not the one that you can eat. And in digital experience organization, this is the sub-organization where I'm coming from, we are making sure that all of these appliances are smart and connected. And this experience consists of multiple layers. First one is electronics. This is electronics. So it's electronic platform and operation systems that enables this digital experience on appliance level, on firmware. After that, we have connectivity. It's a huge IoT backend system and IoT cloud that works as a proxy between firmware and consumer interfaces. And by consumer interfaces, I mean mobile applications, voice integrations, and on some models, even UI of appliance itself. And as platform engineering team, also known as SRE or DevOps, what we do is we are trying to provide best developer experience to our product teams by automating some layers of software development lifecycle. And we are doing this by building our internal developer platform. So internal developer platform consists of multiple models. So first thing what we did when we started to implement IDP, which is internal developer platform, we decided to automate infrastructure provisioning. So right now, all developer teams can provision their infrastructure resources in a very flexible and independent way without being blocked by SRE team, or like waiting while we will pick up ticket and do something for you. Next one is service onboarding, especially backend services. So with this automation, we are providing integrations from the scratch when you're building your backend service, like, for example, CI/CD pipelines, secret management, integrations for environments and different EKS clusters. And recently, we started to be more interested in cloud costs because our product grows, more platforms, like platform grows, more appliances is on the market. And we became really interested to see how much it costs to support and enable one specific feature. And the recent model that we are working on and what I will talk about today is API platform. But before we'll go deeper into technical details, let me quickly show you how this consumer experience looks like. So I have a client, a customer, a very lovely lady here. She put her clothes in the washing machine, but later she got distracted and completely forgot to turn it on. And then she was like, oh my goodness, I have clothes in my washing machine. So she has two options what to do. First one, she can go and physically turn on washing machine, which is boring. Or she can turn on her phone and open the app and turn the washing machine from there. We're trying to make life of our customers easier by providing smart and connected appliances. But what is behind this consumer experience? So, mobile application works as a primary interface for our clients. And we have connectivity platform that handles all requests that is coming from this mobile application, like to enable you and other clients to send commands to the appliance, receive some real-time information or data, get your personal statistics and recommendation. And this connectivity platform is built on numerous microservices, each of them providing their own set of APIs. And our developers work with those APIs every day to ensure that all integrations and functions that we have works perfectly for our connectivity platform. And interestingly, we noticed that mobile application as interface is not enough for our customers. And there is a growing demand from GitHub users who wants to connect to our connectivity platform to build their own smart home solutions. And when we heard about it, we were like, well, that sounds like a good idea. Let's do something about it. And we did. We built external developer portal. So right now, any customer can go and officially use our APIs with proper authorization and authentication layer to build your smart home. And in terms of APIs, right now, we have even more of them to take care of. It's like we have our internal developers, we have external developers. We also have private, and internal APIs. So imagine I have a user and I have my endpoint. And this user sends a request to my endpoint. And it takes approximately 20 milliseconds to achieve this. Can you please raise your hand if you are sure that you can list all steps that this request is going through? Well, if you can, I truly admire you, because I would definitely forget something from this list. So, as SREs, as DevOps people, as developers, it's our goal to ensure that each step of this journey works and functions perfectly. But what are there other challenges in API management except for technical ones? So I mentioned that we have 3 major domains. And because of specification of each type of appliance, different teams might use different technology stacks. So it can be more than one, it can be legacy one, and we should support all of them. Right now, we're also in the end of huge cloud migration from one provider to another. But you know that there is no migration that can be done just like that in one day. So we still need to keep an eye and maintain both of them. And each cloud provider provides their own API gateway, which also do not make our life easier. Connectivity platform that we have is a really big system. And there we have not only REST APIs, there is also Kafka, event streams, MQTT protocols, GraphQL, maybe something else that I'm not even sure about. And don't forget about different environments. So I have a challenge for you. Remember the list of resources from previous slides? Now try to provision all resources for this in dev, stage, and production environment, multiply it by 3 or more regions, try not to lose anything, and specifically, try not to lose your mind while doing this. And that sounds like challenge accepted and failed at the same time. And with different technology stacks, with different clouds, with different appliances, each team might have different views on APIs. So, for example, if I would be a mobile developer, I wouldn't really care about how your API is set up on backend. I mean, like, do you have Theme Firewall or not? Not really my business. What I want to have is to get the response to my request fast as possible. And I, as a backend developer, I don't want to expose my API until I will make sure that this API is secured and do not expose any sensitive information. So we are not the same in these terms. Well, imagine we went through all this journey and my endpoint is finally exposed to the public. So can I easily forget about it and move on and take another task from the backlog? I wish, but I cannot, because we also need to set up proper API monitoring. We are interested in error rate, because we don't really want to miss a signal that there is some issues going on that blocks our customers. Same goes for latency. There might be a bottleneck that slows down our application. Security attacks. We want to find all potential vulnerabilities that our API has. And we really don't want any bots abuse our API for several reasons. One of them is that it might lead to the increased cloud cost, and second, it can slow down application and API response for real customers. And all these points were not set and discussed in like 1 or 2 meetings. It was a continuous journey that continues even now. So let's take a trip back in time and see how we work with APIs in 2015. At that point, we were like quite small digital experience organization. We had only one product in our connectivity platform, and having API definition in Swagger and some simple CI/CD pipeline to expose them was quite enough. But as years goes, our product also grows. And in 2019, we decided to switch to Open API specification and started to adopt infrastructure as code approach. And infrastructure as code is a very efficient and powerful solution, which gives more freedom and more flexibility to your teams, to any other team. But it also requires to gain extra knowledges. Like, first of all, your developers should get familiar with infrastructure. Like, how does it connect it? Like, what kind of resources out there? And it also requires for developers to learn a new language, like a Terraform or CloudFormation, maybe something else. And we decided to make this transition for our developers easier. And at this time, we decided to build our IDP. And how does infrastructure management looks like with IDP? So we, as a platform team, we are defining templates, like set of different resources. IDP fetch this information from our Git repo because it's written in Terraform code. And what is required from developer teams? Just go to very nice web UI, select the template for the resource that you want to deploy right now, for example, Redis, or maybe like service or anything else. Fill in required parameters, like it can be the name of your database, size of instance, basically anything. And IDP will provision this resource under the hood while you take your coffee break. IDP is built based on Spotify's open source framework, Backstage. And if you've been here yesterday, you might know that Adrian talked about platform engineering and Backstage specifically. So what is nice about Backstage? It allows you to customize your internal developer platform. It's open source, so it kind of saves you money. And also, you can contribute to the community. So by doing this really, really good thing for other people. And as our product grows, more people, we have even more teams now. And at the point in time when our platform reached approximately 100 APIs, it became really hard to maintain and control what is going on there. And we decided to adopt API federation. So this is how API landscape of connectivity platform looked before. Each product has its own API gateway. And between actual business service and API gateway, different teams might have a different models. So some teams might implement extra security layer. Some of them might forget about it. Some decided they want to set a rate limitation of throttling configuration, even though there is no need in this. And this is how API landscape looks with API federation. So instead of having multiple gateways, we have only one entry point, which gives easier access for internal developers and for external developers. We have federation layer and product layer. And federation layer right now is maintained by SRE and platform team, also known as us, and we have core services there. So with this approach, we know that all requests that goes through API gateway to the real product services goes through configured, control, and secured way. Product layer allows product teams to focus purely on business-driven APIs. So they can implement some extra control or extra personalization, maybe some slightly change API definition, but they don't really worry about core basic stuff. And we're also quite happy about it. So first of all, we make life of our product teams easier, and we get control over APIs back. So API federation is a set of tools, design principles, and infrastructure that allows you to have easier access point, one access point to all of your APIs, but still gives you a governance with federation layer and gives you flexibility for your product teams. Well, okay, we have API federation. We know that everything is configured in one place. But unfortunately, at that moment, IDP does not support automation for API provisioning. And okay, we have API federation right now, which is in our hands. And we decided to fix that IDP does not support APIs. And at this point of time, we decided to build API platform. And right now on market, there are plenty of API platforms, different one. So what exactly we are looking for? First one, we want to be vendor independent. So we did some research, and I would say 90% of API platforms that you can find can give you API monitoring, API deployment, but only if you will use their API gateway. And we don't want to stick to one more vendor. It also leads to, we don't want to do any infrastructure changes. So as I mentioned, we are in the end of cloud migration. We have established API gateways. We have established APIs. So why would we need to do any changes that just to have API observability? It doesn't make any sense. We also want to have not only monitoring, static page. We also want to have automation for deployment, because we really like to automate stuff. And as we have our IDP, which developers use on almost every day, we don't want to make their life harder by forcing them to have one more open tab in the browser where they can go and check all APIs. We still want to follow our approach that everything is an IDP. So API platform that we are looking for should be integrated and compatible with IDP. And unfortunately, we couldn't find anything on the market. So we decided to build our own. And this is how API management looks right now for us. So we have developer teams who defines the API in a Git the same way as infrastructure is a code. We are using open API specification. API platform detects those changes and shows it back to the user from very nice UI. What developer team should do is just go to API platform and apply those changes. So like, developer can select which region, which environment, what specific endpoint they want to provision. And after that, API platform will handle all required resources with Terraform and integration and automation. By using SDK, API platform will show back all changes. So you as a developer, you as a user, still have one single point and nothing to worry about, like to check what is going on with your APIs. And what is going on with your APIs, we also can collect metrics to show you. It can be any source, like if Prometheus, it can be Datadog, or maybe something else that you might use. And here's a quick sneak peek of how it looks for users. So we have project-oriented view. We know which project, who is an owner, and what is going on with project from what is going on with project's APIs. Like, is there any issues? Is there anything that we should be worried about? And this is the main view that I, as a former backend developer, find really convenient because all information that I use more or less on a daily basis is here. Like, I can see where this endpoint is deployed. Is there any security that I need to find? So, for example, some of the endpoints here, they are using API key security. Some of them also require authorization. And I can see in which regions this API is enabled. So for me, it's enough. Okay. Thanks. Thank you. And as we build tools for our developers, we are really interested to hear what they think about all this stuff, because we don't want to waste our time and build tools that no one uses. So we do frequent surveys, and you can see that Feelings is the name of our IDP. Feelings is quite popular, and surveys are also not being ignored. So this is the average number of sessions that we have in IDP per month. So our company is international, and we have teams from different countries, and you can see 3K of sessions in IDP. It means that developers really use our tools. And I tried to measure how automation of API deployment helped us. And we just starting with one of the new products. And it's without automation, it took for us approximately 1 week to deploy all APIs for products in 5 environments. Dev, staging, production, multiple regions, well, you know the story. And with automation, it would take approximately 3 days. Why 3, not 1? Well, because we have coffee breaks, because we have some technical issues, right? Nothing is perfect. But it still streamlines our lives as SREs, and each time streamlines our development. But more to come. Right now, in version 1 of API platform, we have only basic setup, monitoring and provisioning. But we don't want to stop only on those steps. In the future, we also want to implement drift detection, so to show you real changes and real difference between what you defined in your Git resources and what do you have in your cloud. Same goes for more advanced security layer and cost analytics. So in digital experience and in Electrolux, we are really became more FinOps oriented, because we think that it's really important to understand how our cloud cost is built, what is most expensive things that we have, what are the things that we might get optimized. And for that, we built a couple of tools. And we also think that sharing is caring, and that's why we decided to open source them. So right now, we have 2 FinOps tools available for you. First one is Cost Exporter. Basically, it's Prometheus dashboard, where you can have your cloud cost aggregated into one single dashboard. And the second one is InfraWallet. InfraWallet is a Blackstage plugin that allows you to see detailed information about your cloud cost. It not sticks to only one provider, so we support multiple of them. And to be honest, with InfraWallet, we found in digital experience organization several things that we want to optimize. So this tool is really powerful, and I encourage you to go and check. We also have plans to open source our API platform once it will have more fancy features than just monitoring. So please, let's stay in touch, and it's been a pleasure to be here. Thanks a lot for listening, and I hope you got some really new or inspiration from this talk. Thank you.
Alina, you know that I'm the one who comes with the very difficult tech questions.
Please go ahead.
So I have one for you, very special. What's your favorite Electrolux product and why?
Well, I hope if you paid enough attention to my presentation, you already know the answer. It's vacuum cleaner.
Okay. So I have some more, not as complicated questions.
Okay.
What is the main reason for your cloud migration? Have you considered running on-premise or hybrid approach?
Okay, so for cloud, it was also quite a journey. So first one, we started with on-prem solutions. It was back in 2013. I was not in the company yet, but I know that we had on-prem solutions. As we started to grow more products, it became really hard to maintain all this stuff. And from cost perspective, I think my manager, they decided to go and calculate what it will be much better. Will it be better to hire more SRE developers to maintain all this infrastructure, or maybe we should go to the cloud? And we decided that going to the cloud is much better. We picked one provider. I will not tell his name because it's a secret. But unfortunately, it was not suitable for us. We had some problems. And that's why we decided to move to another cloud provider. So basically, a very agile way to understand what your company and what your product requires.